Okay, so the last objective from 5.5 is talking about what is a normal probability distribution. This is a big, big, big idea. Big idea. This is like one of those monumental times in your math careers. Learning about a normal probability distribution is very important. So, 3 important facts about a normal distribution. First, they have the same overall shape. They are symmetric, they are single peaked, they are bell shaped. Most of the time, or many times, a normal distribution is called a bell shaped curve. Okay. The mean, mu, is the midpoint, and it will be the same as the median. And the standard deviation measures the variability, as we always know. Again, remember the mean is this symbol mu, and the standard deviation is this symbol sigma. So down below, I have two normal distributions. One's kind of short and fat, one's kind of tall and skinny. Notice that right in the middle below the peak is your mu value. And then notice here this width here. So note the points at which the change of curvature take place. Change of curvature. So again, if you were to trace this side, it's hard to see, but once you find that curve point change, I get it. You're kind of just like fudging it. It's okay. That is a distance of sigma on either side of the mean. Distance of the standard deviation on either side of the mean. So this distance right here is your standard deviation. And again, that's going to show how spread this is. So obviously this short and fat one has a bigger standard deviation, and this tall and skinny one has a smaller standard deviation. So this is a bigger standard deviation. This is a smaller standard deviation. And again, it's just about the width. So again, when you're tall and skinny, that change of curvature point right there, that's where you're going to measure your standard deviation to. Notice that both of these curves is going to have an area equal to 1. The area is going to equal 1. So notice why one is shorter and fatter. There's more space out here, more space wide, right? Look at this. We call these the tails. Look at the space under the tails, right? Versus this one, look at these tails. There's no space because most of the data is around the center. That's why your standard deviation is smaller. It's less spread. So that standard deviation really plays a big part into the shape of your normal distribution. So keep that in mind, right? Keep that in mind. Okay. Big, big, big deal. All right, here we go. So it says in baseball, a player's batting average is the proportion of times the player gets a hit out of his total number of times at bat. Suppose we select a Major League Baseball player at random and let X equal the player's batting average. The probability distribution of X is approximately normal, with mean mu equal to 0.261 and standard deviation sigma equal to 0.034. Sketch the probability distribution. Label the mean and the points that are 1, 2, and 3 standard deviations from the mean. Okay, so I don't overcomplicate this. This is basic adding and subtracting, okay? So first of all, the mean, because I'm approximately normal, the mean is going to go directly below the peak. So here's my mean. So there's 0.261. Okay. And now my standard deviation of 0.034, that is what I'm going to add and subtract to the mean to get my first standard deviation. So to get the first standard deviations, which will be this one, this is the positive first standard deviation, and this is the negative first standard deviation. Again, if you draw that mean line and you find the change in the curvature right around here, this distance is the standard deviation. And it's the same on the left and the right. So to find these 2 points, I'm simply going to take my mean of 0.261, and I'm going to add and subtract the standard deviation of 0.034. When I do this, and I'll just use a simple calculator, the 2 numbers I get, 0.261 minus 0.034, when I do the minus, I get 0.227. And when I do the plus, I get 0.295. So the 0.227 goes here. It is 1 standard deviation to the left or below the mean. And the 0.295 goes here. It is 1 standard deviation above the mean. Now, how do I find the points that are 2 standard deviations away? Well, you could do it 2 ways. Number one, you could take the mean and you could add or subtract 2 times the standard deviation because you're 2 standard deviations away. Or you could take these two numbers, 0.227 and 0.295, and you could subtract another standard deviation and add another standard deviation. But any way you do it, you're looking for 2 standard deviations below and 2 standard deviations above. So I'll do it the way I did it here, 0.261 minus 2 times 0.034. I get 0.193. And I'll do 0.261 plus 0.003, plus 2 times 0.034, and I get 0.329. So those go here and here. And then lastly, I'll do the minus 3 standard deviations and plus 3 standard deviations. So to do that, you need to take the original mean and add or subtract 3 times the standard deviations. 0.261 minus 3 times 0.034 is 0.159. And 0.261 plus 3 times the standard deviation is 0.363. The 0.159 goes down here. The 0.363 goes here. And this is how you create a normal distribution. Mean in the middle, increments of 1 standard deviation added to the right, increments of 1 standard deviation subtracted to the left, and there you go. Okay. So hopefully this is pretty self-explanatory, and you're able to draw a lot more normal distributions from here on out. Okay, thanks for watching, and we'll see you next time.